Hey folks, Winston for Carbide 3D here. A wavy wooden flag is one of those classic CNC projects that's both a great showcase of the kinds of unique things a computer-controlled machine can do, and something you'd be proud to show off in your shop. It's also one of those things that at first glance may seem a little more complicated than you're willing to tackle right now, at least from scratch, and that's evidenced by the thriving online market for digital wavy flag files meant for CNC use. But with just some basic computer drawing skills and a 3D CAD/CAM program like Carbide Create Pro, anyone can put together their very own wavy flag model customized to their liking, and it'll only take a couple minutes to set up once you understand the process. In today's video, I'll give you an overview of how I created this 3D carved wooden flag, starting with nothing but a US flag SVG straight off the internet. Now, disclaimer up front, this won't be a complete step-by-step tutorial because there are some steps in my workflow that rely on third-party software you may or may not have. Programs like Affinity Photo and Affinity Designer. These are image and vector graphics editing programs that I personally favor, but there are plenty of other comparable programs on the market, both paid and free, that will also do the same things. Programs like Adobe Photoshop or CorelDRAW or Inkscape. Pick the software tool that works for you. I will also be sharing the Carbide Create file for this project up on CutRocket, so if you want to download that file and dissect how I have everything set up, you're more than welcome to. Okay, I think that's enough of an introduction, let's get into it. Here's the gist of what we're going to do. First, we're going to get an SVG file of a flag and clean it up where necessary. Then we'll make a grayscale height map to represent the waviness of the flag. Next, we'll use the modeling features in Carbide Create Pro to mash up the features of the SVG with the height map. Some toolpaths will be made, and then we'll cut the flag out. The video will be chapterized below, so if you want to see something in particular, you can jump to that section. Before I can do any of the design work, I need to know how big my project is going to be. The official federal spec US flag has specific proportions, 19 by 10. Because of that relatively large prime number in the ratio, it'll be easier to approximately size my desired flag and still arrive at nice round numbers if I design this project in metric units. With the stock material I have at my disposal, the final dimensions I settled on were 760mm wide by 400mm tall. Because of the size of my project and the amount of 3D information that needs to be captured to produce a smooth flowing result at the CNC, I'm going to set the model resolution to extreme. Please note that resolution levels beyond very high were added in Carbide Create builds 8.16 and later, although it's not necessary in many cases. If you want to make a very large 3D carving, this can help. I will also add that this model resolution dropdown only matters if you're doing 3D work in the modeling workspace. It does not affect designs based on vectors. The material I'm working with, more on that later, has a usable thickness of 23mm, and I want my zero height to be at the top of my stock. Everything else here is pretty much personal preference. With the scale of my project established, I'll begin the design process by downloading an SVG file of the United States flag. This one's from Wikipedia. This SVG needs a little bit of work before I can use it though, because if you bring it directly into Carbide Create, this is what you get. I don't really see any stripes, and there's only one star. And despite Carbide Create's ever-improving feature set, to fix this file I will need to resort to another software tool that specializes in vector manipulation. If you happen to be lucky enough to find the perfect SVG file for the flag you want to make, or maybe you're just not ready to tackle the learning curve of adding another software to your workflow, feel free to skip the SVG Repair chapters in this video. For everyone else though, let's take a quick look at some areas where a third-party software will be necessary. First, the white stripes of the flag in this file appear as simple lines in Carbide Create. That's because in a browser, those lines are drawn with an exaggerated width, also known as stroke. Visually, it looks correct, but it doesn't actually bound an area. There's not enough information to create a toolpath from this feature. To permanently force that stroke representation of the stripes into rectangles, I'm going to use a function in Affinity Designer called expand stroke. Might be called something else if you're using another program. I'll delete the lines that the old white stripes were made of and keep the expanded stripes that are the rectangles. Now, when I save the SVG and bring it into Carbide Create, you can see we have boundaries that mark out the extents of the white stripes on the flag. They're not perfect because they actually extend behind the canton, but we can work with that. Running the original file through another vector graphics editor has actually already improved the star situation as well. Now we can see all the stars, although they're still pretty messed up. But that's an easy fix too. Going back into Affinity Designer, you can also see the reason Create was having trouble with the stars. In the original SVG file, there are repeating patterns embedded within patterns of stars. It might technically be legal in the SVG specification, but it's pretty ugly to work with. I'll select all the stars by clicking and dragging, and then hit the Add function in Affinity Designer. This is kind of like the Boolean union operation you might use in Create. Here, it bakes the stars into a 10-sided polygon representation where the shape is defined by the perimeter. With the stars and stripes fixed, we can use Carbide Create to make the remainder of the adjustments needed. I'll open up the SVG file where I've performed the preliminary fixes and then scale it to my desired project size. Now, first off, this file has some open vectors. We can't do any 3D modeling with them, so I'll use the node editing tools in Carbide Create, specifically the join vectors function, to close up the left sides of these rectangles. And then once we have the union and flag profiles closed up, I can do a Boolean subtraction to shorten the white stripes that overlap the canton in the Wikipedia file. This is all the SVG rehabilitation that's needed to get a complete set of flag vectors, but I also elected to do a little bit of cleanup here, creating some self-explanatory layers and moving vectors around. This is what I ended up with. Now I'm ready to create the wavy elements. Before we get into making our height map though, it's worth reviewing what a height map actually is, because some people don't have the right expectations. A height map is a way to store 3D information in a 2D file, like a JPEG or a PNG, where each pixel's brightness corresponds to a particular vertical displacement. Darker values usually represent low points, and lighter values represent high points. These are super useful for CNC relief carving because they allow you to create complex or organic surface shapes from common image formats, and they aren't as bulky as an STL from a file size perspective. Now, can you take a picture on your phone and use it as a height map? Technically, yes, but the results aren't going to be pretty. Remember, lighter areas are going to be higher up on your model and darker areas are going to be lower. If I snap a photo of my dogs and try and create a relief carving out of it, the results are going to look kinda nightmarish. Shadows and dark fur create sunken depressions. Light areas, regardless of if they're meant to be foreground, the main subject, or the background, get raised up. A good rule of thumb is if your source material looks realistic, it's not going to make a good height map. You're going to end up with a 3D model that looks more like an alien landscape than your original subject. A true height map should look more like an X-ray than a photograph. The exception to this rule would be if you were to make a lithophane, but that's a project for another day. So given what we know about height maps, how do we translate the waviness we want in a flag into a grayscale image? Well, let's take a look. The ripples we want in a flag are really just lines of high spots and low spots, ridges and valleys. If we were to look at this image of a real wavy flag and try to manually color code the high spots and low spots, you can see the pattern we'd end up with here. A height map of ripples in a flag is just alternating stripes of black and white, and the spaces between crests and valleys would be represented with a gradient. So let's try our hand at making our own waves for a rectangular flag. In my preferred image editing program, Affinity Photo, I'll make a canvas that matches the aspect ratio of my project. Since my flag is going to be 760 by 400 millimeters in size, an image canvas that's 7600 by 4000 pixels seems appropriate. I'll draw some black lines with the hardness of my brush tool cranked all the way down. This creates a soft, blurry stroke on the canvas, which is desirable for what we're doing. I'll sort of sculpt out where I think ridges and valleys should be. This part is more art than engineering, and it's going to be somewhat subjective. I like to draw my lines at a slight angle, and for an element of randomness, sometimes I'll draw some stripes wider, or I'll switch to a white brush to narrow some of my black stripes. You'll get a feel for it when you give it a shot for yourself. Anyway, this is the sort of result I ended up with, and I exported it as a PNG file, which is generally a higher quality format than JPEG. If your image editing software supports a 16-bit workflow, that will give you an even better result. Okay, now we can jump back into Carbide Create. If you've never used the modeling features in Carbide Create before, I'd recommend playing around with them first to get a feel for what each of the options does. Draw some shapes, push some buttons, and make some mistakes. A little trial and error will go a long way. The main thing to understand is how components work and how each subsequent layer gets superimposed on top of the previous one. But even if you're not super familiar with how 3D modeling works in Carbide Create Pro, I think you'll get the hang of it by the end of this video. Let me really quickly summarize what we're trying to do before we get into the computer work though. This is the flag I'm making. Each of the primary colors of the flag are set at different relative heights. The red stripes are meant to sit higher than the rest of the colors. The blue background of the canton is slightly lower, and the white stripes are the lowest part of the flag. The stars will protrude from the canton by about 3 mm, and the waviness will add up to 19 mm of variability to the whole thing. If we draw out a sort of abstract cross-section of it all, this is what it looks like. In case you're wondering, the height of each layer was chosen so that the sum of everything would stay under 23 mm in height. That's because the wooden glue-up I'm using as my flag blank has a top layer that is, you guessed it, 23 mm thick. I don't want parts of the flag to dig into a different layer of that glue-up and expose a grain mismatch like what happens when you cut through layers of plywood. How do we make this in Carbide Create? Let's look at the vectors in my workspace. I have stars, the union, white stripes, and the overall flag profile. Since I don't have vectors that are explicitly for the red stripes in my design, I'll have to create those stripes by subtracting away everything that's not red. So I'll start by building up some volume to sculpt within. I'm going to select the rectangle for the outline of the flag and hit Add Shape. I'm going to generate a flat, uniform plateau 3 mm thick. That gets us this result. Next, I'll select the box for the flag's canton and hit Add Shape again. This time, I'll recess the selected region down by 1 mm, choosing the Subtract option under Merge Type. Here's what that looks like. And then, to make the white stripes, which is the lowest part of the flag design, I'm going to select the stripes in my design, hit Add Shape, and then subtract away 2 mm from my original model. That gets us to this point. So far, this is all really basic. Now, to switch things up, we're going to add some volume to create the stars. I'll click and drag to select my star profiles, click Add Shape, and then make them 3 mm tall. But instead of building these up with a flat uniform profile, I'm going to have them follow an angled profile. This is what that looks like. Up until this point, we've been adding and subtracting from our 3D model by picking a vector and adding a shape component. Now it's time to bring in our Wavy grayscale height map. I'll select the outline of the flag as the area for the height map to be applied to and click Import Image. After I select the PNG file I made, this is what I have to work with. I'll scale the vertical displacement of this height map to 18 mm and add this component to my model. This step right here is the keystone behind a large swath of Wavy flag CNC files you find online. We've just taken a little know-how in an image editing program, run the results through Carbide Create Pro, and created a mesmerizing 3D flag. Now, when it comes to toolpathing, you can absolutely get by with the standard 3D machining approach of dropping a roughing toolpath over everything, and then a finishing toolpath over everything. The entire flag will get milled to a uniform degree of detail. This simulation shows an example of what that would end up looking like, and there's absolutely nothing wrong with that. But I think there's some room to optimize this process. Let's try something different here. I'm going to elect to finish the stripes not with a ball end mill, but with a flat end mill. Now, conventional wisdom has always been to use ball end mills for 3D finishing, but in the areas where the red and white stripes meet, a ball end mill is going to leave a filleted corner. This reduces the crispness of that transition, and having a nice hard break between the different sections helps to make the end result that much sharper. If I use a smaller diameter ball end mill for finishing, that fillet will get smaller, but then I'll also need to use smaller stepovers to minimize the cusps between passes, and that means a longer runtime. By using a flat end mill, I can take a larger stepover while still getting a sharp transition between stripes. And even though a flat end mill can't dip into the valleys of the flag's contours as well as a ball end mill can, the surfaces of this flag are shallow enough that most people won't notice where some extra material was left over. For the flag I ended up machining, I used a finishing toolpath with a 1/4" end mill and a step over of 0.6 mm, resulting in a reasonably quick machining time for the stripes. And since the part I care about more are the stars, I can take the time savings from the stripe machining and invest it into the 3D finishing of the union. The stars will get a finishing path using an 1/8" ball nose end mill with a 0.15 mm step overs, achieving a level of detail that would take ridiculously long to do if applied over the entire flag. There are a couple other operations in my project that I didn't talk about, like the contour toolpath to cut out the flag's outer profile, but there's nothing clever about them. You can dissect them for yourself in the project files for this flag. I don't know about you, but I would rather talk about the machining now. This is the material I'm using for my flag, and I've both applied double-sided tape to the bottom and stuck some clamps around the perimeter. My 0 is set just inside the bottom left corner of my stock to make sure I don't accidentally chop off part of the flag's edge, and since I've previously flattened this material, I don't need to worry about high spots when I 0 off the top of it. Here is the initial roughing phase of the flag machining. This was done with a 1/4" down-cutting flat end mill, and the biggest thing I'm having to contend with here is the fact that the construction-grade lumber that I'm using here likes to leave long fibers that clog the dust boot. If I could do this all over again, I might instead try a roughing end mill to disrupt the formation of these strands, and use a larger diameter end mill to get through this material in fewer passes. Or if I didn't have to worry about the budget, I'd make this out of walnut or something. The next thing I'm going to do is run that finishing pass over the stripes. I'm just taking advantage of the fact that this toolpath uses the same end mill as the roughing toolpath. The machine won't need to stop and ask for a tool change, which means I can let it run unattended while I do something else in the shop. And the final act of this 1/4" end mill will be to cut out the profile of the flag. I'll need to remove the clamps for this step. You could do this cutout last, but if something went horribly wrong, like, oh, I don't know, I didn't use enough tape and the flag blank came flying off the table, I would much rather it happen sooner rather than later, after I'd invested hours and hours into machining the stars. As soon as the cutout was completed, I corralled my stock with clamps again and switched to my 1/8" ball nose end mill. Then I let the machine get to work on the stars. I actually ran this pass twice, the first one leaving a tiny skin of extra material over the stars, and the second pass barely doing any work. I was paranoid that too aggressive a cut could cause chip out at the star's edges. In hindsight, I don't think this is necessary as long as you're using a nice sharp cutter, but I figured I'd mention it anyways. The end result looked pretty good to me, straight off the machine, but as with any CNC project, there's always going to be some degree of manual finishing required if you want something to look the best. I'm not going to go too crazy here though, because you won't notice a lot of the small things from more than arm's length away. I'm just trying to take off any fuzzy bits that are left over. To finish this piece, I'll apply an oil-based finish because I absolutely do not want to raise the grain and have to sand away more fibers. In this case, I'm using tung oil. And the final result is something I'm pretty happy with. I think it's a great demonstration of what a couple vectors in a digital doodle can accomplish. Now, before I close out, I'd like to point out a few things I might change if I were to do this again, and some general things to look out for. First, if you want to paint your flag, having stars that stand out proud is a nightmare. You can't really mask around them well, and the only way you could paint the Canton blue would be to do so by hand. What would work better in this case would be to set the stars down into the flag. Second, I think using an 1/8" end mill for finishing the stripes would have worked out better than the 1/4" end mill, because even though the surface contours are pretty shallow, there are still some areas where you end up with what I can only describe as puddles of material that a flat end mill can't dip into. With a smaller diameter end mill, this effect would be minimized. The end mill just needs to be larger than the step over of your finishing toolpath. Side note, you can also get puddles of leftover material at the edges of the flag too. When you select the bounding box for a finishing toolpath, you're telling Carbide Create that the center line of the finishing tool must stay within this vector. When I picked the profile of the flag for roughing and finishing, this is what was happening at the perimeter. In areas with a negative slope, the end mill couldn't drop down far enough to clear away all the desired material. Using a smaller diameter end mill helps, or you can create a slightly oversized offset boundary for the finishing toolpath to work within. This offset should be slightly less than 1 radius of your finishing tool. So for a 1/4" end mill, 6.35 mm, I would offset the boundary for my finishing toolpath by 3 mm. And one last variation I'll just throw out there is that some materials, like aluminum, tend to show tooling marks pretty openly. But if you take an artistic approach to how you do your tool pathing, this can actually be an advantage. Here I'm applying my finishing toolpath with different directions and even stepovers to create additional visual contrast between the stripes, the union, and the stars. Ultimately, there are many ways to do any given thing on a CNC, and what I've shown in this video just happens to be what works for me and what I like. I encourage you to try making your own wavy flags, and if you do, please share the results on the forum, or even better, cut Rocket. That's all for today. Good luck and have fun machining, folks.